we'll take a look of how to take GIS data, geospatial data from an open data source and import it to Rhino via Grasshopper using the Heron plugin. So first thing to do is go to the package manager and look for Heron and install it, then restart Grasshopper and Rhino. Second thing to do is to download data from the internet. Go to the City of Calgary's open data portal, browse data and look for park sites, park site servers, hydrology, street center line and 3D buildings, and for each of these data sets, export and check for shapefile and download it. You'll get folders like zip folders like this that you need to extract to these folders, and in each of these folders we'll only reference the shapefile inside. Let's go back to the Grasshopper. First we need to set from here on, we check GIS tools and we go to set spatial reference and we set the reference, the official reference projection of Calgary. Control C, a panel, Control V, plug it here and we check if it's successfully, the reference is set to the Alberta one with its name, and we call the component import vector and we don't clip to a boundary, and with the file path component we select the hydrology, which is the lightest one, so that we can locate the area we want in Calgary, open, and we plug it to file path and we wait for a little bit for the data to load. After a couple of seconds, once data is loaded, we click in the component middle mouse button and we go to the zoom on data and we zoom on the area we want. Let's do downtown now, and we create a curve component and we will reference a rectangle here, a small one. Make it as small as possible, just focus on your area and reference it here. Set one curve and I will internalize it in this script, save it and then plug it into the boundary. And now only the features, the geospatial features within this rectangle will be plotted. So once this is out, I forgot to clip to the boundary. Now once only the features clip to the boundary are loaded, I will do exactly the same thing. I just Alt and copy this component and I will go to the select existing one and I'll go to the other ones. Street lines, shapefile, okay, wait for it. Same thing. There's a good practice is that press solution and disable the solver, then you can copy this over and over again so that we can load multiple files without set one existing file, 3D building, shapefile, then boundary, set curve, set existing file again for the side, parks, shapefile, open, and now we have all of them here. We have here the, I just have to disable, re-enable the solver. We can see after loading that we have the parks, the buildings, the streets, and the hydrology. So we can select all of them and press Ctrl Q to hide them, and I recommend using the preview instead of baking. Just use the human line weights preview and the human preview material. This is just to preview the shapes. So I'll preview the river with the material 1 and I can set any color, diffuse color, any, and then for the street lines I'll plug in, I need the thickness and I need a shader. Alt copy this one and the shader, no, thickness, shader, and I'll make them a little bit darker, and these are the lines. And the next one is the buildings. I'll use the shader one with the swatch and I plug in the buildings and I can choose a different color for them. And the last one is the parks. I plug in the parks and I set another color for them. And here is a quick way to get the data. And we can also extrude the buildings in 3D if we want to. I recommend another plugin to make life easier when extruding, which is the offset mesh, not this one, offset mesh. And this one is by Pufferfish, and it makes life just easy. And I will set both sides 1 true, and I'll plug in the mesh, and I need the distance. So if I plug the distance 1, I will have all of them extruded by 10, but this is not what I want. I want the actual height of the buildings. To do that, I will keep these things here organized, Control J, and I'll keep this here, each component organized, and I save. And for this one, we need to get, so we have here the fields, and from these fields we have the ground elevation and the rooftop, but we need which one is the Z. So to get which one exactly, you just go back to the data, and we go back to the 3D buildings, and we see here the different fields we have. So we need the ground elevation min, which is ground elevation 1, 2, 3, 4, 5. So it's 5. It's ground elevation 5, and we need the rooftop Z, which is rooftop elevation 1, 2, 3, which is 3. So we need 3 minus the 5. So what we do to get this one, we use set, we use key value search, and we plug in the keys, which are the fields, and we plug in the values, and we need this one twice. For one, we will look for rooftop 3, and for the other one, I'll copy this one, we will look for ground elevation 5, and the difference between these two will be the height. So I'll just choose a -1 minus the other one, and I will get the value. This is negative, I need to make it positive, switch them, and these are the heights of the various buildings. I will just plug this one into the distance, and I will get each building. Oh, it's the opposite, so the mesh normal is upside down. I'll just switch it, and this one I'll just plug it into geometry, and I will have this with Control Q, and that's it. I can customize from here without liking any features I want. If I want to add the parks hardscapes, I can do so by copying this one and referencing the park hardscapes shapefile, and I can get it. Just give it a second to load, and I will change this one to a more gray look. If you have this Z fighting here, you can just move the geometry a little bit up, move by Z, and let's give it 0 to 20 slider to adjust the movement up, and I plug the geometry here, and I can move it slightly so that it doesn't touches the. Once that it's good, and I hide this one, Control Q, and I keep only the preview here. And this is how you can get quickly some parts in a boundary in the city of Calgary or any city that offers free open geospatial data.